From the previous discussion, we have known for the exponential function y equals a times b raised to x, if this b, the base, is greater than 1, this function will be increasing. We say this kind of function is an exponential growth function. So next we will examine the property of the increasing function, increasing exponential function. First, let's use some specific values to demonstrate the property of this exponential growth function. First, we assume x equals 0. Y will be 100. Why? Because this is 0. This one will be 1. So y will be 100. Go on. If x equals 1, y will be 300. If x equals 2, y will be 900. If x equals 3, y will be 2,700. X equals 4, y will be 8,100. The calculation is quite simple. You just need to plug in the corresponding x value here. Then you will figure out this power, then multiply by 100. You will get the corresponding value of y. Alright. Next, let's examine the first difference. The first differences. Alright. You can use this value to subtract this 100, you will get the first difference. That is say 300 minus 100, it will be 200. Next, you use this value to subtract this value, you will get the first difference. That is say 900 minus 300, it will be 600. Go on. You use this one to subtract this one, you will get 1,800. 8,100 minus 2,700, you will get the corresponding first difference. It will be 5,400. Then you can figure out the second differences. This time you need to use this one to subtract this one. That is say 600 minus 200, it will be 400. And this one minus this one, it will be 1,200. This one minus this one, it will be 3,600. Right? That is say we can use this table to demonstrate the relationship between every value that is here. Alright? Okay. Now let's observe this table. You will find out some interesting properties for the exponential growth function. That is say, the first differences, they are different from one another. So we say the first differences are not constant. Alright? But the ratio of the successive first differences is the same. That is say, if you use this number, divide this number, you will get 3. This is so-called ratio. You use this number, divide this number, you will get the same ratio, 3. You use this one, divide this one, you will get the same ratio, 3. Alright? That is say, each value after the first is 3 times the previous value. Alright? Each value after the first is 3 times the previous value. Okay. Similarly, the ratio of successive second differences is the same. That is say, this one divide this one, it will be 3. This one divided by this one, also 3. Alright. So we say this ratio is the same with this ratio. That is say 3. This 3 is just this base. Alright? So let's summarize the property of the exponential growth function. All right, if you locate the corresponding points in the Cartesian plane, you will find out we can sketch the graph like this. This point should be 100, all right? Because this point 0, 100, and the graph should be like this. Okay, if we locate these points, it is 1, so the corresponding y-coordinate will be 300. If we locate this point 2, the corresponding y-coordinate should be 900, and go on. You will be able to locate the corresponding points in the Cartesian plane. All right, but you will find out this is an increasing function. All right, so the graph comes from quadrant 2 ends in quadrant 1. Okay, because this is an increasing function, so we say the independent variable increases by a constant amount. The corresponding dependent variable increases by a common factor. All right, this constant should be this 3. That is, this is 100, this is 300, this is 900. All right, but the x increases by the same amount. That is, every time increases by 1, but the corresponding y-coordinate increases by a common factor, that is 3. And the graph increases at an increasing rate. At an increasing rate. Here, this is the ratio. That is, this is 100, this is 300. All right. This number divided by this number, it will be 3. Next time, this y-coordinate divided by this y-coordinate is also 3. So you can find out the graph increases at an increasing rate. The next property, the finite differences show a repeating pattern. The ratio of successive finite differences is constant. Here it is 3. Okay. We can locate the next point here. It is this number. Next, this point, it is 4, 8,100. Okay. So for the exponential growth function, you will find out the properties. The finite difference is a constant. The graph increases at an increasing rate. The independent variable increases by a constant amount. The y increases by a common factor, which is 3. Here, it is just the base. Do not forget, for the exponential function, we can divide the graph into 2 parts. This part must be above this straight line. This part must be below this straight line, but this branch will approach x-axis, will never touch x-axis. This is an increasing function. That's it.